This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIIMS and NEET. Now we will learn the work done by a constant force. So if a constant force F is applied to the body such that it makes angle theta with the horizontal and the body is displaced through the distance s, then we have to calculate the work done by the force. So as we have already learned that the work done by force is a scalar quantity W, and it is the dot product and the scalar product of two vectors, force and displacement. So work done by a body or work done by a force is the dot product of force and displacement. So now we just consider the case when the force F is applied on a body which makes an angle theta with the horizontal and body is displaced through a distance or a displacement equal to vector s. So this is shown in this figure. Here the force F is making an angle theta such that the component of force along displacement or along the x-axis will be F cos theta and the perpendicular to it will be F sin theta. So basically we just break the force F into two components, F cos theta and F sin theta. So by resolving force F into two components, F cos theta is in the direction of displacement of the body. Because of this force F, the body moves from point A to point B and covering a displacement equal to s, and F sin theta is the force perpendicular to the displacement of the body. As the force perpendicular to the displacement is making an angle theta is equal to 90 degree, and it will not contribute any work for this. That is, if the force F sin theta, if we consider the work done by force F sin theta, then F sin theta into s is making an angle cos 90 degree. So this force F sin theta will not make any contribution in the work, and the contribution, the component of force which make contribution in this work is F cos theta. So it is written here, since body is being displaced in the direction of F cos theta, therefore work done by force in displacing the body through distance x is given by W is equal to F cos theta into s, as the angle between F cos theta and s is 0 degree. So it is equal to Fs cos theta, and work done by body is equal to dot product of F into s. So basically if the force is making an angle theta with the displacement, if it is the direction of displacement and this is the direction of force F which is making an angle theta, then the work done by body is equal to dot product of F dot s, and it is equal to Fs cos theta. Fs cos theta. So basically work done by a force is equal to a scalar oblique dot product of force and displacement of the body. The force component which is perpendicular to the displacement will not make any contribution in the work done by this force. It is very clear to you. Now we will see the case when more than one force acts on the body. So suppose that a number of force F1, F2, F3 and so on are acting on the body, and it shifts the position vector R1 to the position vector R2. So basically, as we have learned that the position vector or the change in position vector gives you the value of displacement. That is, I just write here that displacement is equal to change in position vector. If you have doubt that how this displacement is equal to change in position vector, you just go through my notes in the motion in straight line and you will come to know. Anyway, I just redraw here also. Suppose this is x-axis, this is y-axis, and the body is moved from point A to point B. So the position vector of the body when it is at point A is given by OA, while the position vector of body when it is B is given by OB, and this is our displacement. The vector AB is our displacement. So basically by triangle law of vector addition, OA plus AB is equal to OB, and AB, which is our displacement, equal to OB minus OA, that is change in position vector. So basically displacement is the change in position vector, and due to the application of various force, suppose the body shifts such that its position vector changes from R1 to R2, then work done is the force work done is basically a dot product of force and displacement. So here the force is the sum of all forces and displacement is the change in position vector. So this is basically our displacement, and this is our F net, or sum of all forces, which we denote by F net. So the work done is F net dot vector S. So it is the dot product of all forces and displacement. So clearly the work is a scalar quantity, and because of this the work done by two separate forces may be added algebraically. So algebraically we can add work done by two separate forces. We need not to add it in as a vector addition. So this is shown in the figure that a body is subjected to various force F1, F2, F3 and F4. Now as the displacement is along x-axis or in the horizontal direction, so you just get the component of forces along x-axis, and the component of force F1 cos theta is along x-axis. Again for F2 there is no component along x-axis. For F3 it is minus F3 along x-axis, and for F4 it is equal to F4 cos alpha. Here F4 is applied on this way, and it is making an angle phi with the x-axis or the horizontal direction. So if I break this force, then it is composed of two components. One is the F4, this is our force F4. So one is F4 cos phi, this is F4 sin phi. This is making an angle phi. So that direction will be F4 cos phi, F4 cos phi, and this is F4 sin phi. Clearly this is our F4. Clearly F4 sin phi will not make any contribution towards the work as it is perpendicular to the displacement, while F4 cos phi will make a contribution. So here the work done will be given by, as per this figure, the work done will be given by F1 cos phi plus F1 cos theta plus F4 cos phi minus F3 into S. So this is the work done by body. So clearly we see that we are just adding this the work done by these forces algebraically. We need not add this work done vectorally. So first work done is F1 cos theta into S, second work done is F4 cos phi into S, and third is the minus F3 into S. The work done due to F2 will be equal to 0. So when the multiple forces acted on body, then the work done can be calculated in this way.